I have a three-step process for converting an equation to different units. The first step is to find or generate an example. The second step is to convert all the variables to the desired units. And the third step is to use the example to find the new constant. So the first example I want to use is the force of gravity, universal gravitational force. And I want to convert this from SI units to CGS units. For my example, I'm going to generate it from a mass 1 equals 1 kilogram, mass 2 equals 1 kilogram, R equals 1 meter. And I'm going to generate it just by plugging it into the formula. Force equals 6.67 times 10 to the negative 11th times, that's the SI unit for this, times 1 over 1 squared, which gives me 6.67 times 10 to the negative 11th newtons. Now I'm going to convert all variables to the desired units and use the example to find the new constant. So actually, first, before I do that, I'm going to reform the equation so that it is G equals FR squared over M1, M2. And so all of these things are going to be converted to the new units. First of all, 1 Newton is 1 kilogram meter per second squared, which is 1,000 grams times 100 centimeters per second squared, which is 10 to the 5th centimeter grams per second squared, which is also known as 10 to the 5th dyne. So this number here, when I convert it, is 6.67 times 10 to the negative 6th dyne. The others will be fairly simple to plug in. 6.67 times 10 to the negative 6th dyne times our radius is 1 meter, which is 100 centimeters squared, divided by our masses, which is each going to be 1,000 grams times 1,000 grams. And this should give us our new G. And it turns out to be G equals 6.67 times 10 to the negative 8th centimeters squared per, dyne centimeters squared per gram squared. Let's do another very similar example, which will involve the equation that centripetal force is equal to the gravitational force of a body in orbit around the Sun. And the centripetal force is going to be omega squared r, m omega squared r, and the gravitational force is going to be g m, let's say capital M, little m, over r squared. And omega is 2 pi over t over the period squared, r, m, equals g m m over r squared. Let's put our r cubed over here and put everything else on the other side. G m, I can cancel out the m's there. G m t squared over 4 pi squared. So we've got an equation that goes r cubed equals g over 4 pi squared, that's our constant, times mass times the period squared. And now the example I have in this case is r equals 1 astronomical unit, m is the mass of the Sun, and t is 1 year, because we got this one example. It's an empirical example that the Earth goes around the Sun with radius 1 astronomical unit in a period of 1 year. And our actual equation for this would be r squared equals mt squared. And basically I put a little constant in here. Actually, let's write it this way. G over 2 pi 4 pi squared equals r squared over mt squared. So this is finding or generating an example. So we've got that example that r squared over mt squared equals g over 4 pi squared equals 1 right here. 1, and the actual units are astronomical units squared divided by the mass, solar masses, times year squared. Whoops, this is cubed. R cubed, astronomical units cubed over solar masses years squared. Step 2 was convert all variables to the desired units. Let's convert this to SI units. So if I said R equals 150 million kilometers, no, 150 billion meters, 150 million billion meters, or just 150 times 10 to the 9th. The mass of the Sun is 2 times 10 to the 30th. 2 times 10 to the 30th kilograms. And the period of a year, we want that in seconds, and that is 31.6 times 10 to the 6th seconds. 31.6 million seconds. So plugging that example in to find our constant, r cubed over mt squared equals, we'll have 150 times 10 to the 9th cubed divided by 2 times 10 to the 30th and divided by 31.6 times 10 to the 6th squared, and that comes out to be 1.69 times 10 to the negative 12th. And that is, if I multiply that by 4 pi squared, you can see our old friend 6.67 times 10 to the negative 11th. So this is equal to g over 4 pi squared. Oh, and this is in, I should put in the units here, because it's not just a number. This is in meters cubed per kilogram second squared. So this does give you r cubed over mt squared equals g over 4 pi squared. So that's equal to 1.69 times 10 to the negative 12th meters cubed per kilogram second squared. And that completes step 3 of using the example to find the new constant.